Given f of x equals x squared plus 2x minus 6, and g of x equals negative x plus 1, evaluate and simplify the following. Part A, f plus g evaluated at 3. So there's two different ways we could do this. We could first determine what the sum of the two functions f plus g of x is, and then evaluate that function at 3. That would be fine. Or we could evaluate this as f of 3 plus g of 3, because you can separate the two functions and or do them together. It doesn't really make any difference. I'm not sure that either way is easier than the other. I'll do part A this way, and then I'll do part B the other. So for part A, we have f of 3, which would be 3 squared plus 2 times 3, which is 6, and then minus 6, and then plus g of 3, which would be negative 3 plus 1. So this becomes 9. Those actually cancel out to 0, so that's just 9. Negative 3 plus 1 is negative 2, so this would result in 7. So that's one way of evaluating, just split them up. Another way of evaluating, so if I have f minus g evaluated at negative 2, is to do f of x minus g of x first, figure out what that function is. So I would have x squared plus 2x minus 6 minus negative x plus 1, which would be x squared. And be careful because this negative distributes into all parts of this set of parentheses. So it's 2x plus x, so that's plus 3x. Negative 6 minus 1, so that's minus 7. And then now we can get f minus g of x evaluated at negative 2 just by plugging into this function. So negative 2 squared plus 3 times negative 2, so I'll just go ahead and write that as negative 6 minus 7. So this would be 4, that becomes positive 4. Negative 6 minus 7 is minus 13, so negative 9. And I could have done it the same way that I did in part A. It really doesn't make any difference at all. Part C, we want to find f times g evaluated at 0. So I'll just do this one as f evaluated at 0 times g evaluated at 0. F evaluated at 0, if you'll notice, all the terms with x would disappear, and you'd just be left with negative 6. G evaluated at 0, all the values of x would disappear, and you'd just be left with 1. So negative 6 is that answer. And then lastly, in part D, we want f divided by g evaluated at negative 1, which I'll just do as f of negative 1 divided by g of negative 1. So the function f being x squared plus 2x minus 6, this would become negative 1 squared plus 2 times negative 1 minus 6 all over g of negative 1, which g was negative x plus 1, so this would be negative of negative 1 plus 1, which would be 1 minus 2 minus 6 all over 2. 1 minus 2 is negative 1. Negative 1 minus 6 is negative 7. So we would get negative 7 halves.